Now it's time to look at a negative velocity and a positive acceleration. So what is this positive acceleration going to do to the negative velocity? So here's our example. A brick wall is set at 0. So the brick wall is our reference point. It's the 0 on the position graph. Bump ahead slows down just in time not to hit the wall. He's going to start off away from 0. So he's going to start off at the top of the position graph. And let's look what happens to him. All right, so he moves a lot at first. Then the distance that he moves every second gets smaller. You can see that. His position numbers are up here. And by finding the difference in those position numbers, we can find his velocity. So from 50 down to 32, you have to go down 18, then down 14, down 10, 6, and then a negative 2 at the end. So his velocity was negative the entire time, but it was becoming a smaller negative number, right, because he was slowing down. We can find the acceleration. And so despite him slowing down and having negative velocity, the acceleration actually turns out to be positive. See that? To go from minus 18 to minus 14, you have to go up 4. Acceleration of positive 4. So whenever velocity and acceleration have a different sign, you're always going to have a slowdown. So velocity is negative, acceleration is positive. You have to have a slowdown in this case, in every case. What would the position versus time graph look like? We plotted the position numbers here and then connected them with a line. You see that the line curls. It's actually curl upward for positive acceleration, but you see that the line slopes down for a negative velocity. It's steeper in the beginning because it's faster in the beginning, and then it's flatter at the end because it's slower speed at the end. What about the velocity versus time graph? So we're just going to graph these numbers, like put the minus 18 in between 0 and 1. We'll put the minus 14 between 1 and 2. You get this graph right here, right? And then you just connect those all with a line, which happens to be straight. And so this is like the negative side of the graph. I didn't show the positive side, but the negative side would look like this. And it's just going to get as fast negative, then it's going towards 0. The slope of this line should tell if the acceleration is going to be, it's a positive slope, so we're going to have a positive acceleration. Doing rise over run, you see that it goes up 20 over 5. What is 20 divided by 5? 20 divided by 5 is 4. And 4 is also the acceleration that we found using the numbers. So once again, the slope of the velocity graph always tells us acceleration. All right, so that's what happens if you have a negative velocity and a positive acceleration. It's always going to slow down, and it's going to slow down while it's moving towards our reference point.